My name is Tab Sullivan. I am a senior scientist here at Integral Molecular in Philadelphia, Pennsylvania. The overall aims of Integral Molecular are to find tools to study membrane proteins better. So the company was founded on this idea that you could make membrane proteins a more workable protein by encapsulating them in a viral-like particle. So that viral-like particle, the lipoparticle, was the founding technology of the company. The reason that the founders came up with this idea is because they were all virologists in grad school or their postdocs, and they were studying viruses and realizing that they could encapsulate all sorts of membrane proteins in the outer envelope of a virus. But because they're virologists, they're also interested in working in the virology field. And for a long time, Integral Molecular has been making reporter viruses, both with dengue and Zika, and now, of course, SARS-CoV-2.
My name is Rebecca Rimkunis, and I'm the project leader of the shotgun mutagenesis epitope mapping team at Integral Molecular. On the epitope mapping team, we are looking at where antibodies are binding the spike protein, which is responsible for the entry of SARS-CoV-2 into human cells. SARS-CoV-2 is the virus causing COVID-19. And with epitope mapping, we are able to understand how and where antibodies are neutralizing the SARS-CoV-2 virus. And by doing this and understanding the mechanism of action of antibodies, we can better select for lead therapeutic candidates and also understand how vaccines are working to neutralize the virus. We are also can look into how antibody cocktails that can be developed for therapeutic use, and these are a combination of several antibodies that have different mechanisms of action that strengthen the neutralization of the SARS-CoV-2 virus. On the epitope mapping team, we mutate every amino acid of a membrane protein to an alanine and then see which mutations are causing a loss of binding of the antibody to that target. And this way we can identify the epitope. The iQue allows us to read a 384-well plate in under an hour, which is really a game changer for us because we can screen several antibodies across hundreds of these alanine mutations in a single day. It is also very easy to use, even for new users who have little to no experience with flow cytometry. The iQue gives us the sensitivity to detect binding of even low binding antibodies, and also has sensitivity so that we can see the difference in binding for an antibody between the wild type membrane protein and the mutated protein. At Integral, I think using the technology like the iQue will allow us to accelerate our studies and discovery and characterization of antibodies towards membrane proteins for treatments such as for cancer and also for the COVID-19 pandemic we're experiencing currently. I think using this technology will allow us to screen larger panels of antibodies and be able to more quickly characterize these antibodies.
In the future, we want to be able to support the companies that are developing vaccines and therapeutics. We want them to be able to use our RVPs to determine the effectiveness of either their therapeutic or their vaccine. To that end, we're doing things to make sure that we're staying on top of what is happening to SARS-CoV-2 as it passes through the human population. And as therapeutics are added and vaccines are added, viruses have the capacity to mutate. The nice thing about the alanine scan library that we've already talked about is that any single one of those alanine mutations can be made into a reporter virus. So then those can be tested for their ability to escape the vaccine or the serum response, the neutralizing response, or the monoclonal antibody that's being used to block the virus.